I think people will keep coming, but maybe we can start our presentation. Stacey, thanks a lot for finding time to join us today. It would be really great to learn from you and hear about what you're working on. Today's presentation is about how to accelerate collaborative machine learning, considering COVID and how this world is changing. Like the distributed team in different time zones is, it's many companies sort of following this, and that's why collaboration, right, and facilitating collaboration between teams, it's even more important. So today we will learn from Stacey, who is a deep learning engineer at Weights and Biases, how at Weights and Biases they're solving this problem, what kind of tools they're building. Thanks, Stacey.
Great, thanks so much. Hi, everyone. Thanks for taking the time today. I'm a deep learning engineer at Weights and Biases, and today I'll be sharing some tools and strategies for more effective collaboration on machine learning projects. And I'll be using case studies and visuals and live examples from my work at Weights and Biases, but I hope you'll get general lessons and approaches that are useful, regardless of which frameworks or tools you use. And as machine learning and data science practitioners, I believe we have unique leverage in choosing where we focus our efforts, so which data sets, problems, and applications we advance, and also that the more accessible and transparent and collaborative the process of building and deploying models for these becomes, the safer and better the collective outcomes. So I'll be focusing on a few of our benchmark projects, which are open and public collaborations on impactful problems, and in this case, environmental sustainability, AI safety, and tracking political campaign financing. And I hope to show you how you can use tools like Weights and Biases to streamline workflows and facilitate collaboration on any project by connecting and tracking all of the pieces of code, data, configuration, metrics, interactive analysis, insights, random notes, presentations, revisions, debugging, all of that for everyone on the team. And while I know machine learning is far from a magical solution, I also hope to encourage more of us to consider how our skills might help address some of these planetary scale challenges, especially in the current moment of overlapping crises. So in an earlier versions of this talk, I've given a poll informally to the audience about what folks think the top challenges are in open collaborative machine learning. And the most common answer was getting started. So just running into issues, setting up the existing code or environment, and followed by debugging, which would be hitting other problems, regressions, or getting stuck. And coordination was the third runner-up. So this is tracking or organizing next steps or figuring out who does which parts. And interestingly, in that poll, no one voted for shipping or making sure others can use your model or reproduce your results, which either means that part is very easy or very few people actually get to that point in such projects. So I hope to address all of these. And first of all, I really briefly want to explain what Weights and Biases is and how it works, so you can follow my examples and visualizations more easily. So what is Weights and Biases? You can think of it as a system of record. So the way a sales team might use Salesforce or an engineering team might use Jira to track and organize everything that they do. Weights and Biases is a central, lightweight, and flexible set of tools. And what's really crucial is that we're framework and infrastructure agnostic. So whether you're using PyTorch or TensorFlow or XGBoost, whether you're running in the cloud or in your local setup, or even especially if different folks on your team are using different setups, you can use Weights and Biases. We have specific features for common use cases that you might encounter. So artifacts for versioning your data and pipelines, tables for interactively visualizing your data, experiment tracking to see all of the different experiments or runs of your models that you've tried, sweeps for optimizing models, and reports for collaborative analysis and reproducibility. And I'll be showing examples of how we implement these and talking about how the general strategy is useful. Also, just to get really concrete, WannaDB is a Python package that you can install using pip or conda. You can import it into your project, and then it's just a few lines to work with it. You call wandb.init to give your project a name. And this is where all of your experiments or runs will be organized for everyone on your team. You can save any experiment configuration, say hyperparameter settings or the name of your training data. And then you define and train your model. That part's still up to you. And as you do that, you can log any metrics from your training script. This could be accuracy and loss, of course, but it can also be rich media, videos, audio, custom HTML, 3D, interactive molecules, and so forth. So now that I've introed the tool, I'd like to go into a few case studies on projects we've done and highlight where the collaboration features were helpful. So the first is Dropwatch, and this is in collaboration with Andrew Hobbs. And this is a project looking at how we can better monitor droughts, and it has a concrete impact on areas around the world. This started with a project that Andrew was doing with folks in Kenya, where a program has been active since 2011 using index-based livestock insurance to monitor drought conditions, and when drought happens, transfer resources to folks in the region who are affected, these are pastoralists or nomadic farmers, and give them money to support their households. And this program has been running for a while, and of course, with climate change, we might see the impact of droughts in increasing areas around the globe. The existing methods that it uses are good. This particular program has used normalized difference vegetation index, or NDVI. And you can see visually, if you look at data from April 2018 versus April 2019, we have a lot more red in April 2019, and you can use that to estimate drought. But the problem is that this measure does not distinguish between edible and inedible plants, and inedible plants can stay green during the droughts. So the idea was to crowdsource expert labels of forage quality and then use computer vision to estimate drought conditions. And through the ILRI, they funded lots of human experts, these nomadic farmers, to go to specific locations and label them with the forage quality. It's a number from 0 to 3 of how many cows that area could support. And then these are correlated with satellite images, and we have over 100,000 of them for those same locations. And these are much easier and cheaper and faster to get than having humans go to the location. And now we have a supervised learning problem where we hope to predict forage quality using only the satellite images. And this is a challenging task. We started in August 2019 with a very simple benchmark, and since then folks have iterated on this with more advanced architectures and submitted papers to various conferences, including CVPR in 2020, where folks built on this work to just advance the process of training in this. It's a massive data set. It's weakly labeled. We have the pixel for the center image in the satellite. And there's a lot that you could do to improve these models. And the exciting part is how the community has built on this initial data set code that we provided to accelerate this research. And especially with COVID, the project has been on pause, and the challenging part, of course, is to deploy these models to reality. And that requires partnering with local organizations on the ground. And in the future, as we keep working on this, we hope to extend the approach to other crops like cassava and rice, and also use it for other regions, such as just expanding beyond Kenya with this program, and hope that it's also relevant for other agricultural metrics, which could be anything that's georeferenced to the ground level, so yield, forage, pests, etc. And that was a whirlwind overview of the project, but I'd like to talk about what's been really helpful for working on this project, especially as Andrew and I were in different locations for most of the pandemic, and all of these folks who have contributed to the benchmark are located around the world. So a detailed logging of everything that's happening in the experiment is, of course, very useful. So here I'll, alongside each run, show the validation images, and you can see where the clouds might be obscuring some of the visuals and just the variety of images that we have to deal with. It's helpful to see metrics in real time and be able to look them up easily. I don't have to take a whole extra step to process a bunch of numbers and turn them into visuals. And then Andrew and I, or anyone involved in the benchmark, can see exactly the loss curve for any of these runs. I can also go in and look up the configuration and details for past experiments. So here I have a screenshot of a particular model I trained on August 12th, 2019. And I can right now go in and copy and paste this git state and this run command, and I could recreate exactly this experiment on from my terminal, and the exact state of code, the exact state of the training data. And this is really useful for reproducibility because I know that this is as close as I can get to exactly that run. It's also useful to track system metrics. So this is a screenshot of, basically you can think of this as tracking NVIDIA-SMI. So what percentage of the GPU was I using? How much memory was allocated? Things like temperature. And because this is tracked automatically for each run, if you enable it, it's very easy to find the historic data and worry less about needing to debug it because it's all automatically saved. Finally, having a dynamic dashboard where all of these experiments are tracked and organized is really helpful. Here are a bunch of my different hyperparameter settings and all of the result metrics associated with those. And in this dashboard, in weights and biases, I can filter by different parameters. I can sort and group. I can, see how my choice of architecture, like the size of my layers, or how much I dropped out, can contribute to loss and accuracy, etc. And I'll hop into some live visuals in a second. The next steps on this project, as I mentioned, are a lot of architecture exploration, hyperparameter tuning. There's also a whole interesting area of data augmentation where we can look into how to remove some of those clouds, how to focus on different spectral bands from the land satellite images. Of course, there's also class imbalance, and that we have a lot more drought labels than not. And we're not actually using the ground photos yet. So there's potentially some work there as well. And hopping briefly into a live example of a weights and biases report, here you can see that in the report I can include text, links to useful resources, and here I've made a chart of all of the submissions to the benchmark, and I can include details about different folks' approaches. And what's nice is I can also see, okay, here's one of the top performing runs, Dropwatch 12, it looks like. I can go in here and look up exactly the metrics that this participant to the benchmark has logged. See their validation accuracy going up, the loss going down. I can see, the state of the code that they logged, and all of this is much easier than trying to, read the paper that they submitted, email them to ask about the detailed training configuration, and so forth. The next case study I'd like to talk about is Safe Life, and this is a project with Carol Wainwright and Peter Eckersley and the Partnership on AI, and this is looking at safety in reinforcement learning. And I'm sure folks have heard about the incredible advances in deep reinforcement learning. We have strategy games like AlphaGo and StarCraft, where the deep nets are beating humans. We also have, some success in robotics. Project Loon is building these stratospheric balloons. I think it might be on pause actually, but those balloons were navigating with reinforcement learning to adjust their height as they bring internet connectivity to rural areas. And while we're seeing a lot of success in this space, there's also lots of challenges. It's challenging in these systems to set very precise goals or get them to adapt to change. An example of adapting to change might be that if you're building a robot that is trained to drive on sidewalk, what happens if it veers off into grass or dirt? How do we generically train the system and anticipate all of the things that might happen in the open environment, right? And we might also want it to explore safely if there's certain states that the robot can only reach after driving off a cliff, right? Then we have to figure out how to set up a safe way to test those. Learning from human preferences is one way that some of these challenges have been addressed, but is also an active area of research. You know, if we have a cleaning robot instead of a navigational robot, how do we tell it that it's okay to get rid of, you know, the stash of recycling, but not these important documents that were maybe sitting on the table? And finally, that gets at you know, the general challenge of avoiding negative side effects. So with a lot of these systems, we have to very precisely enumerate both what we want them to do and what we don't want them to do. And in this area, we don't really have general solutions, you know, how to avoid side effects, period. Real world systems need constraints, and there's still loopholes like reward hacking. So here in this probably now famous example, we have a reinforcement learning agent that's a boat learning to drive through this multi-level maze. And here is a clip where the agent has figured out that if it just goes in a loop and keeps hitting these bonus targets, then it actually maximizes the score and never finishes the level. And you might say, okay, we've poorly specified the problem here, right? We need to include in our reward function that the agent needs to complete the level. But as you can imagine, there's lots of details like that, right? And maybe a simpler example, you might think like making a cup of coffee is a really simple situation, right? But if the agent is trying to make a cup of coffee as fast as possible, you might get served water that is still super boiling, or they might spill all the beans everywhere and grind too much coffee because that would be faster, right? And so we have to figure out how to specify not doing anything else. And what this project tries to get at is how to do this safely with a benchmark. And so we've created this, this is mostly Carol's work, created a learning environment for these agents that has procedurally generated levels. And these oscillating patterns, they follow Conway's game of life rules. So at any time step, if a cell has 2 or more neighbors, it will continue into the next time step. Otherwise, it does. And in this way, we get a bunch of procedurally generated levels that try to mimic the real world and its unpredictability. And there are a few different task types. There's append, where the agent has to place markers in a goal state. There's prune, where the agent removes the red markers. And then there's navigate, where the agent has to solve a maze. And crucially, the agent can't know what the different markers actually are, because that would be cheating, you know, which ones to avoid, because then we would be encoding the specific rules that we're trying to get the agent to learn. So for this project, we set up a collaborative benchmark, and here you can see some screenshots. There's a leaderboard for submissions, and for each submission, you can see exactly the code, how the levels are generated, etc. There's also a human leaderboard, because you can also play this game as a human. And now that I've set up the problem, I want to talk about some of the helpful tools here. So looking at this work in a custom dynamic workspace is really helpful. So here I'll show an example of let's hop into my workspace first. I'm spoiling the reveal. So here I have a bunch of my experiments. You can see the names. They're training different agents on different tasks. You can see all of my hyperparameter settings and results here. I can scroll through and organize, you know, here's actual videos of the agent playing that game during training, and I can expand the section for validation, and also see metrics across all of my runs. You know, what was the average for side effects, what was the score, etc. And this is useful as I'm making progress on the project to to compare different changes that I've made to see how the agents are improving. But I really also want to highlight that each of my teammates can have a workspace as well. And I started out showing you Kat's because she's grouped the agents by task type. And this kind of view might make it easier to analyze and compare, across tasks. Like it looks like the maze solving task has the most side effects on average, which kind of makes sense because in that one, the agent has to potentially explore a lot more of the world. It also looks like the average score is highest for the prune, the one where the agent is removing blocks. And so maybe that, that kind of task is easier. And multiple teammates can share any of these views through the default workspace. So I can, find a nice view here. I can copy it to my workspace or copy it to the shared default workspace. I can also create a report directly from here after I've configured, some analysis that's useful to me. I'm going to hop right into a report that I've already made. Again, you can see these live examples. And I also want to show that these charts are interactive, so I can select a different subset of runs to show, and these will naturally update. So I can, for my readers, set up different subgroups of experiments that they could then choose to compare and analyze. And here I have a screenshot of the same thing. I want to hop briefly into versioning because that's also really crucial and maybe harder to show in a report. But tracking the precise state of the job, as I mentioned, the code is something that we save. The data set and the models as a graph is really useful for precise comparison. Here I have a toy example where each node is a step in my workflow. So I'll have an upload job that creates some raw data, and that raw data I can load in and split, say in 6 different ways to create some balanced data. And then that can be read into some train jobs and some inference jobs. The train jobs produce models, which are then read into the inference jobs, and these log test results. And in the weights and biases UI, all of this can be explored interactively, and I can trace back, which specific versions of data and models were used in all of my experiments. I can, take notes and iteratively refine and annotate and eventually standardize these workflows so that I know that other participants in the benchmark or anyone else working on my project is using, the exact same version of the data set with identical images or, in this case, procedural level generation settings. And even compare the code. So here I'm choosing 2 different versions of the Safe Life training code, and we can see that between V5 and V17, there were some changes made to how the navigation task levels are created because it looks like the original ones were taking too long. I'm gonna hop ahead a little bit. There's also useful visualizations for hyperparameter tuning in this project. There are ways to explore patterns in model performance. Maybe this one is one I'll show live. So here I've logged for 40,000 episodes. I've logged the training video. And then for each video, we have the side effects that that agent happened to induce, the length of the episode, the reward, and whether the agent succeeded, and the score. So one thing I can do here is group by success to see, which agents succeeded and not. And now I'll get, well, most of them did not succeed. This is an early run, but we did have 36 that succeeded. And I can see the individual videos here. The agent is going to the goal state. But what's even cooler is I can see the distribution of, say, side effects or length. You'll see all of the ones that didn't succeed are at 50 because that's the agent, just getting stuck and not exiting the level. I can do things like dynamically ask questions. What was the average reward, let's say, for agents that succeeded versus did not succeed? It looks like the success 0 agents had lower average reward, which is good. but I might then look at the score distribution. And otherwise, I can ask all of these questions without having to rerun any code, without having to write a different function for my score. I can just plug it in here and experiment with that. I'm gonna keep moving. So lots of next steps and ways to participate in this project. I'm gonna talk very briefly about Deepform, because I realize I'm pushing the time limit right now. This is a project with a bunch of collaborators to basically extract, to use OCR to parse documents, but understand a very general layout form. And we started this looking at campaign financing for the 2020 election, realized that all of this political advertising information is, in the US, it's legally mandated to be public, but it's in tens of thousands of PDFs that have hundreds of different formats. And it's very hard to, if you get a form like this, you can easily find, the amount that was spent on this political ad and who the ad was for, what the station is, right? And you could say, okay, if we have OCR for this, if they all look like this, we could automatically extract the data. But it turns out that sometimes the format looks like this, sometimes it's like this, and there's thousands and thousands of these, and sometimes many pages. And I realize I'm out of time. I can hop to the conclusion, and then if folks have more questions, I can dive more into that project. Does that sound good?
Yeah, sounds good.
Great. Yeah, so that was a whirlwind tour. The general principles I hope I've shown a few examples of is how tracking absolutely everything you can help you record both what you tried and be able to look it up later. Having a workspace where you can configure for your own settings, but also share with others is helpful. You can compare precisely to different versions or different states of code. That can help you make progress faster. And of course, saving and sharing that progress, especially in a form that's connected to all of the metrics and things that you've logged, can really enable this progress. And yeah, thanks so much for listening. There's some links if you'd like to learn more, and I'm very happy to take questions.
Guys, do we have questions? Feel free to unmute yourself and ask directly. I see Steve is asking something, but we don't hear you. Stacey, I have a question. I'm wondering about this first case study that you shared. How did you get access to satellite data?
Yeah, so it's downloaded from Landsat.
So it was publicly available, or?
Yeah. It's with a certain frequency. There's a bunch of different programs. So at some point, Andrew was looking into, if we can pay more money to get more regular or higher quality data. And the publicly available ones aren't updated quite as often.
And I'm curious. So you said that the model eventually wasn't deployed, right? But according to sort of initial plan, who's supposed to deploy that model and maintain that model in production?
Yeah. So in this case, my role is mostly supporting Andrew in getting this project into Weights and Biases and setting up this benchmark, and the organization that's providing this initial data and running this program is who's responsible for it. So it's more of a matter of working with them to update the system to use the deep learning produced metric that we've created here instead of the normalized difference vegetation index.
Okay. Also, in conversation with different companies who have distributed team, one of the challenges that they experience, let's say they have team in Europe, and there are some, specifics how they regulate data, right? Because of the GDPR, and team in the US doesn't have access. Have you guys sort of seen this problem as well when it comes to collaboration? Because in this case, like collaboration between teams is much harder, right?
Yeah, that's a great question. So I've definitely heard about this, and I know that in Europe this started earlier, the importance also of deleting data if someone puts in a request. What we support at Weights and Biases is artifacts. That's our solution for storing data. And permissions on that are at the level of a team. So you could potentially create different teams within your organization that would have different permissions to different data sets if there was a problem across, or not a problem, but just a difference in accessibility across different countries and roles. Of course, we can't prevent people from taking screenshots and sending emails, but at least at the code level, that's how that would be enforced.
Okay, interesting. Guys, do you have other questions? Okay. Mike,
do you deal with model drift?
Not for any of these projects. The way that, if you're asking about how I would deal with that in weights and biases generally, is that the question?
Yes.
Yeah, totally. So I would set up a project where the metrics that I care about would be logged and evaluated on some with some level of frequency, and I would get one of these. The same way I was showing those reports, you could set those up as a live dashboard. So every time I visit that URL, it would update to show, what the latest 10 values logged for that metric were. And I could potentially set up an alert to say, when this metric has, drifted more than 10%, send me a Slack notification or an email. I would need to set all of the frequency and parameters there myself, so we wouldn't intelligently discover when the model has drifted. But all of the infrastructure, sort of cron job pieces, you could set up in weights and biases.
I see a question from Mike. Do you have a training program for the platform?
We have lots of tutorials, and we do occasional, informational talks and webinars that there's lots of YouTube videos as well on our channel, walkthroughs of specific features and examples. And all of that is free. And I'm wondering what the best place, I think if you go to wandb.com, you'll see classes and things like that. There's also, if you go to our examples repo, there's a bunch of examples, but we don't have a WandB class for now. It's a great idea.
I'm wondering, based on your experience, when it comes to collaboration and in general productionized machine learning, what are the sort of main challenges that exist today? Because there are so many tools, right? And weights and biases competitors, so many companies trying to solve this problem. But what the main challenges are still there?
Yeah, I mean, that's a great question. Even looking at these projects, a lot of the biggest challenges are sort of outside of the tools, right? They're sort of maintenance tasks and really getting someone who cares and is the final point person for shipping this thing, right? And maybe that's more of an issue in these open public collaborations where it's less oh, there's a deadline and big finances on the line. I think some of the remaining problems are coordination and getting everyone on the same page, maybe the machine learning team or the subset of folks that are very actively working on this model, they know exactly what's happening, right? But the DevOps team has a sort of a different view, right? Or folks who maybe use some downstream results of this model, they don't actually, maybe they don't need to know the full level of detail, but I think coordinating that, and we hope that folks can do that through reports more easily by having these dashboards and even custom views perhaps for different teams. I think that's one of the the fundamental hard problems. Although of course, all of the other things I mentioned, right, and just figuring out exactly which version of the data set was input to this last production, to the model that's currently in production, right? That's like also still not straightforward, but we're hoping to make it better.
Yeah. Okay, guys, if you don't have other questions, I mean, we can wrap up this presentation, and the video recording will be available in 1 week or so. Also, if you want to connect with Stacey, if you want to learn more what she's doing and how to use weights and biases, I can share this presentation in our bug out Slack, and you can also, I think, connect to Stacey directly, right? And send her email. Yeah, I think if there's anything else, Stacey, is there anything else you want to share with the community?
Yeah, I mean, thanks so much for joining and listening. We're definitely hiring for a bunch of roles, so please check out wandabe.com and you'll find it from there. We also have, we feature work by folks who write reports in our fully connected gallery. And so if you're looking to build a resume, or if you're working on cool projects, we'd love to see and feature some of that work. And yeah, please reach out if any of this is interesting.
Thanks for your time, guys. Please join bug out Slack if you're not there yet, and I will share the presentation and the recording there. Thanks Stacey, thanks for your time, and thanks everyone for joining this talk. Have a nice day.